Hi, welcome to this talk on production scheduling using a spreadsheet solver. My name is Badri Topur and I'm Associate Professor at Rajalakshmi School of Business in Chennai, India. My co-author is C. Swaminathan, Regional Sales Manager at Murugappa Group, also in Chennai. Brakes India is a leading manufacturer of braking systems. They supply to OEMs such as Maruti, Tata Motors and Mahindra, and they also export to international manufacturers. Axletech America is a supplier of high quality transaxles in USA. A transaxle is a combination transmission and axle. You can see one featured in the lower right of your frame. The transaxle is used in tractors, golf carts, lawn mowers and such vehicles. They make transaxles to customer design, and they also outsource standard designs to other companies. So this talk is about one such contract between these two companies. You can see the 6 products, the demand for the 6 products over a period of 13 months. Now this plot may be more revealing. You can see some demand, the variance is in a band between 250 and 750, but for some other parts the variance is outside and it goes down to 0 or climbs up to about 1400. So I suggested to my co-author that we use integer linear program instead of level scheduling that he was recommending. Now this is the result of fitting probability distributions to the demand data, which we tried after creating the deterministic model, and we got okay results. For some distributions, the p-value from the Kolmogorov-Smirnov test was above 0.15, and so the distributions were a good fit. But for 3 distributions, we could not determine the best fitting distribution. So we have not gone ahead with the simulation model as yet. Now the questions we have approached or addressed is twofold. What if you increased production capacity, and what would happen if you had reduced production capacity due to a pandemic, in which case the labor is laid off and they are expected to go back to their hometowns. So what would happen to your production plan? So you can see here the existing production capacity and the contribution margin. We have assumed some inventory cost and inventory starting values. Now this slide you can see that the demand exceeds the production capacity in 4 months out of the 13 months, and this looks like an infeasibility condition. But there's a Wagner feasibility condition which says that if aggregate demand is less than or equal to aggregate capacity, then the multi-period problem has a feasible solution. So this is why this problem has a feasible solution, though some months it looks like you cannot meet the demand. So these are the variables I used in my model, and these are the constraints, the objective function, the capacity constraints, and these are the equality constraints that relate production inventory with the demand. Now this is the solver output. I used open solver, which calls the coin over solver, and you can see the inventory is maintained in the initial periods and in the later periods, and for a couple of periods there's no inventory maintained, and the last few columns are the backlog columns, and you can see there's no backlog except for the second period, the sixth part, and since it's the second period we cannot meet that demand from our initial inventory or from our initial production. But otherwise there's no issue with this order. Now this model can be used by micro companies or medium-sized manufacturing companies who cannot afford the commercial license solvers like Gurobi or the others. So that's the advantage of this solver, of this model, excuse me. Now this is the second scenario where we have seen what would happen if we increased or decreased the production capacity. So there's an extra term in the objective function, sigma ki, capital Ki, and in the capacity constraints you can see this term again, ki, small cap ki, capital Ki, and the capacity expansion cost is varied in a band between $1 to $10. So this is the sensitivity analysis table. I varied the cost of expansion from $1 to $10 per part. Of course, it may be much more in a different range, but for study purposes, I have taken a band like this. Now you can see for the first four rows, the objective function value is competitive with the objective function we got with the first scenario, and for the cost from 5 to 10, the maximum profit is less than what we got from the first scenario. So this would mean we would not advise production expansion, capacity expansion beyond $4 per part. So this is a sample output for one of those cost scenarios. Now what would happen if your capacity dropped to 50% because the labor is migrating back to their home towns or villages because of this lockdown? So we are now facing the second wave, and the labor is in two minds whether to stay in their work town or to go back to their hometown. But regardless, the capacity is affected, and you can see in our model the inventory figures are now in every month, and the last few columns, the last 6 columns, the backlog is significant, and so this means there will be many delays in the delivery of the order. So these are my conclusions. So this model can be used for by small companies that don't want to use the commercial license solvers, and it's also useful for doing sensitivity analysis on your production capacity. And the interesting point is, if the production capacity is down by 50%, the profit is decreased by only 23%. But the disadvantage of this is that the orders may be delayed by many months. Future research. Since we have ruled out a simulation model, the other option is a dynamic programming approach, which has been used previously on such problems. I would like to thank Professor Ravichandran, retired professor from IIM Ahmedabad, for telling me about the Wagner feasibility condition. Professor Ramasubramaniam, Professor of Supply Chain Management at LIBA, Chennai, who told me about OpenSolver, which allowed many integer variables in the model. I'd like to thank the OpenSolver team, which helped me out with a few bugs during runtime. I would like to thank Professor Cantarellis and his editorial board for reviewing my paper and publishing it in the March 2021 issue of GBEA. The references are there in the paper, and I thank you all for your time and wish you all the best in this year.